Hello everyone. Our project is titled Review Summarization and Sentiment Analysis Service. This project was developed by myself, Divyashri Kuntamalla and Sriram Chunduri. In today's digital age, there is a massive volume of online reviews, and as we all know that analyzing these manually is time consuming. Moving on to the first slide, in order to automate this process, our project will offer summarization of reviews to provide concise insights, sentiment analysis to classify reviews as positive, negative, or neutral, efficient storage and retrieval of results for future use and analysis. So, we wanted a solution that is scalable, cloud based, and efficient enough to handle real time analysis of multiple reviews. Moving on to the next slide, to achieve our goals, we used a combination of technologies. Frontend is built with HTML, CSS, and JavaScript for an intuitive user interface. Backend, a Flask REST API to handle user requests and manage tasks. Worker service is developed in Python using NLP models and Hugging Face for summarization and sentiment analysis. Message queue. Here, Redis is used to manage task queuing and fast result retrieval. Cloud services used are Google Cloud Platform, GCP for cloud infrastructure, BigQuery for structured data storage, cloud storage for raw and processing data backup, GKE, which is Google Kubernetes Engine to run all the services in scalable containers. Each component runs in its own Kubernetes pod for isolation, scalability, and efficient resource management. On to the next slide, here's an overview of our system architecture. The front-end UI lets user to submit reviews and check results. Then the REST API processes user submissions and enqueues tasks in the Redis message queue. Then the worker service continuously monitors the Redis queue, processes tasks, and stores the result in. First is Redis, which is for quick retrieval. Then BigQuery for analytical queries. Finally, the Google Cloud Storage for long term backup. All these components are deployed on Kubernetes with Google Cloud Platform, ensuring smooth orchestration, scalability, and reliability. On to the slide 4, we have an architectural diagram. Some of the most important steps are submit a review, enqueue the task, process task, store the results. Fetching the results is the final step. Now, let's dive into the detailed workflow of our system. As a step 1 is submitting a review, here when the user enters a review into a front-end UI and clicks submit, this triggers a request to the REST API endpoint which validates the review and assigns a unique task ID. Step 2 is enqueuing the task. So the REST API enqueues the task in the Redis message queue. This task is stored with the status of queued. Next step goes to worker processing. Here the worker service continuously monitors the Redis queue. When the task appears, the worker dequeues it and performs the following actions. Summarizes the review using a T5 NLP model, analyzes sentiment using the Distil-BERT model to classify the review as positive, negative, or neutral. Step 4 goes in storing the results. The results are stored in the three locations. First is Redis for fast retrieval by the front end, then BigQuery for detailed analytics, finally, cloud storage for backing up the long time storage. Step 5 is fetching and displaying results. The front end UI polls the REST API to check the tasks queue. Once the task is completed, the results are fetched from Redis and displayed in the UI. Now, my co teammate Sriram will continue explaining methods for debugging and testing.
Now, to ensure everything works smoothly, we implemented several debugging and testing mechanisms, such as logging. So logging is an integral part in any of the workflow. We added detailed logs in both REST API and worker service to track the flow of tasks and identify issues. So we can track each pod to identify if there is any error or if there is any issue that has been encountered and there is any bad request from the REST API standpoint. So that's one of the use cases. Error handling, we managed potential issues such as Redis connectivity failures or Google Cloud errors by adding error handling routines. Testing, unit tests to verify individual components like enqueue process, TQ process, task processing, result retrieval, and other components. Integration tests to ensure end-to-end flow of tasks throughout the system. Load tests to check how the system performs with multiple concurrent tasks and identify bottlenecks. Now coming to the demo part. So in this particular project, as part of this, we have created a UI, front-end UI, that actually uh, is helpful in summarizing and providing the sentiment analysis. So in this particular screen, there is a input field and you have submit option, cancel, check status and reset. So when you click on the submit button, an enqueue endpoint will be triggered and it will be stored in the Redis queue, whereas worker would try to poll every time if there is any task for it. Once an enqueue task is actually processed in the Redis, then the worker actively dequeues it after processing it and then stores the results in the Redis queue, which is the cache. Then actively the front end polls for any result in the Redis queue. Then it actively polls and fetches the results, and finally it displays the results on the screen. Like for example, if you see this review, this is one of the Amazon's product review, and it has decent amount of sentences. You can have it from a couple of sentences to many sentences, but we would prefer an average review to be around like 2 paragraphs. So that would help to summarize it more efficiently. So we are using T5 for summarization and Distilbert for sentiment analysis. So when I click on submit, the task has been successfully submitted with task ID. Now the Redis will have the task. And as soon as the Redis actually has the task, the worker polls it and quickly processes it and it stores the results in Redis. Since Redis is very quick, like Redis cache is very quick in actually sending the results. That's the reason we got the results within 1 second actually. So if you see the status, the task has been completed and the summary says, which is a bit concise version of the provided review and along with the sentiment and its score. Like here it is a positive sentiment with a score of 0.99980. And so in conclusion, this particular project automates review analysis by leveraging GCP services and scalability. The system can handle multiple concurrent tasks, and we have identified potential bottlenecks like processing large inputs, which can be mitigated by scaling the worker service pods. Thank you so much.